Okay, so this is number 15 in section 9.2, and I've done a split screen here so I can show it to you in my math lab and draw it out here on the right. And it says, use your graphing calculator to solve this. The transition matrix for a Markov chain is given below. That's the P is equal to that 3 by 3 matrix there in my math lab. And they want to know what limiting matrix do the powers of P appear to be approaching. That's the first question. So in red on the right, I did P to the 100th, and you can see you get 1, 0, 0 for the top row, the bottom row 0, 0, 1, and the middle row is 0.5 at either end, but then the middle, I get to 6.533 blah, 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 times 10 to the negative 23rd. That is a very, 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 very small number. So I went ahead and did P to the 200th, and I basically got the same thing everywhere except that one number in the middle. Now it's in blue, 4.268 dot, 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 times 10 to the negative 45th. It is appearing to approach, because that's what it says. What limiting matrix P do the powers of P appear to be approaching? And so every number is the same except for this one. In both of these matrices, it's getting closer and closer to 0. So every other number, if I highlight those in a different color, you've got 1, 0, 0, 0.5, 0.5, 0, 0, 1, 1, 0, 0, 0.5, 0.4, 0.5, 0.5, 0, 0, 1, 1, 0, 0, whoops, I made a boo-boo right there. Boop, that's supposed to be a 0.5. My bad. 0.5, 0.5, 0, 0, 1. So it's obviously the thing in yellow is approaching 0. So I'm going to come over here to my math lab, click on the box. My toolbox opens. I'm going to click on the matrix button, and I need a 3 by 3. So use these arrow buttons and go up. 3 by 3 magically appears. Click OK. And then I'm going to type in 1, 0, 0, 0.5, 0, 0.5, 0, 0, 1. And excellent. Okay, now the next question shows up. Let me try to make this, we can see it all. There we go. Okay. Are the rows of the limiting matrix actually stationary matrices for P? Now remember, stationary matrix, and at this point I've got the limiting matrix there at the bottom in black. So I'm going to erase this because I don't need it anymore. And what you're going to have to do, and this is kind of a pain in the butt, but remember when they talk about the stationary matrix? The stationary matrix was referred to as S, and the stationary matrix, whoops, if you take S times your P, it should equal your S. And that way you know that you have a stationary matrix. Well, in this case, they're wanting us to use the limiting matrix as our P. It just says, are the rows of the limiting matrix stationary matrices for P? So, let's see. So they are all the rows stationary matrices. So I'm gonna start, let me take the highlights out because I'm gonna use them in different highlights now. Let's go with the first row. I'm gonna let the first row be S, and if I take S times, I'm actually doing this, do you get S? So you have to go into your calculator and do a 1 by 3. You're going to make this a 1 by 3. And of course, this one you'll have to recreate. You'll have to get a new 3x3 and put this into it. And if you multiply it, do you get the 100? And yes, you do when you do that. I've already done this. Then you're going to use this row, and you're going to do this S times the limiting matrix. You want to know, whoops, does that S down there times your P, does it give you the same S, the 0.50.5? And I already did it, and yes, it does. And then you gotta do it one more time because it's asking do all the rows. So now we use this one as S, right? Take S times the limiting matrix P, and you're checking. When I take this S, this bottom row here, times P, which is the whole matrix, do you get that limiting or that stationary matrix? Yes, I got them for all three. So if you get no on these, you'll check C. If you get all of them, you do B. And then if not all of them, not all of them, you say no, only rows blank and blank, use the separate, but it worked on all of them here. So check answer. Nice work. And I got it done. That was kind of a pain in the butt, but that's how you do that one. I hope that helped.